blueprint requires a special print. Most of you are familiar with our print vehicle before and current. What this printout shows, of course, is camber, caster, toe in the front, camber and toe in the rear. For an established blueprint, we need much more information than that. What most body shops and insurance companies are going to need is our print summary, which does in fact show all of the measurements. As you can see, we've got a pretty full sheet of measurements here, which include, of course, my camber, caster, toe in the front, my steering axis inclination, included angle, turning angle, maximum steer for both left and right, rod height, wheelbase, body, wheel offset, lateral offset at the top. And of course, we've got our cross side-to-side values here. Going down, we also have setback, again, our track width differences and so forth. And then of course in the rear we've got our camber, toe, thrust angle. We also have our rod height and our wheel setback to diagnose any values that are bad in the rear. Starting from the top, camber, caster, toe, of course, are tire angles. The steering axis inclination is measuring everything that holds the pivot points to the car. In other words, the strut tower, the unibody, the control arm, the subframe. The included angle, which is next, is measuring everything between the pivot points, which would be, in this case, your strut, knuckle, and hub bearing. What you're looking for here is large side-to-side differences of 1.5 degrees or more. The side that has damages, basically what we're doing, we're cutting the parts into two groups, and then we're going to do side-to-side comparative measurements to establish what parts are in fact damaged. Coming down, we also have the turning angle. That measures the steering arm on the knuckle. In some cases, the steering arm may be on another component such as the strut. It's also measuring the curvature in the tie rod. So if we have a bent tie rod or a bent steering knuckle, steering arm, these numbers will pick it up there. Again, we're looking for large differences of 1 degree or more, side to side. The max steer is measuring center point of the rack. So if the rack has internal damages that we cannot see visually, we can establish that the rack is damaged based off the numbers. Again, we're looking for large differences of 1 degree or more. And then of course we have our offset values, as I explained earlier, to establish that the suspension is in fact square to the car. We have a setback value here. So if we have a caster issue, the setback number will establish that we have in fact a pivot point that is in fact in its correct location, or if it's more than 1/2 of an inch, we can establish that we have a control point that is moved, such as a lower control arm. So as you can see, we've got complete measurement of the car. And again, with our body suspension dimension audit and our printouts from that, we have blueprinted the car correctly so that we can identify damages, and once again, once the repair process is completed, we can also use this printout to verify that the car was in fact restored back to its pre-accident condition, so that the customer has confidence in the job, body shop has confidence in the job, and our insurance partners are confident in the job as well. I hope this presentation has been helpful, and if you have any further questions or concerns, you can contact your local Hunter training and technical support team. Thank you very much.